This video is an introduction on how to apply motion equations to projectile motion problems. First, we should discuss what a projectile even is. A projectile is any object that moves only under the influence of gravity. I kind of like to think of it as an object that is traveling through the air that doesn't necessarily belong in the air for an extended period of time. So a good example of a projectile is a baseball after it is hit by a bat, or a volleyball after it is served, or essentially any object that is dropped, thrown, or projected. An example of something that is not a projectile is an airplane or a bird. These objects move because of forces other than gravity. Whenever we talk about projectile motion, we always have to break the motion to the x and y components. We know that the vertical acceleration, also known as the acceleration in the y direction, is gravity, which is approximately 10 meters per second squared and points towards Earth. In the horizontal direction, also known as the x direction, there's no acceleration since there are no forces acting in the horizontal direction. So let's look at our motion equations in the horizontal and vertical direction. First, we know that since there's no acceleration in the x direction, that the final and initial velocities in the x direction will be equal to each other. And since they are equal, we can apply our constant velocity equation to the x direction. And in the vertical direction, we know that we have a constant acceleration, which is gravity, so we can apply our constant acceleration equations. And in this class, whenever we are analyzing the projectile motion, we will assume that the initial y velocity will always be 0. This means that our objects will be projected straight out instead of projected up or down at an angle. This way we can avoid trigonometric functions. Knowing this, we can simplify our equations, and we find these three equations that we will use when analyzing projectile motion problems. So let's finish this video up with an example. A cannonball is fired from the wall of a castle with an initial horizontal velocity of 120 meters per second. If the wall is 20 meters high, how far from the base of the wall will the ball land? So it looks something like this. We have a castle where a cannonball is horizontally projected at 120 meters per second, and it is projected 20 meters above the ground, and we want to know how far away from the castle the cannonball lands. Now this may seem like a daunting problem, but when we break it up, it becomes actually pretty easy to manage. So the first thing that I should mention is that when we are working with projectile motion problems, since most of these objects are falling towards Earth, we tend to call down the positive direction. So in these problems, we will say that gravity is positive 10 meters per second squared. It isn't wrong to say that gravity is negative 10 meters per second squared, but positive 10 is just the common notation. So even though we are working in 2 dimensions, we really only have 5 different variables as shown. So let's fill in our table. We know that the horizontal velocity is 120 meters per second, and that the vertical displacement is 20 meters. So these are actually the only 2 variables that we know. So we also have these 3 equations that we developed on the last slide. So if we want to find the horizontal displacement, first we're going to need to find time. So we will use our delta y equals 1/2 gt squared equation. We can fill in our knowns, and when we solve, we find that it takes 2 seconds for the cannonball to hit the ground. Now, since we have time, we can now find the horizontal displacement. So here's our horizontal displacement equation, and when we fill in our knowns, we find that the cannonball hits the ground 240 meters away from the castle. So what if we were asked to find the velocity components of the cannonball as it hit the ground? We know that the velocity is constant in the x direction, so the velocity in the x direction is going to be 120 meters per second still. And to find the vertical velocity components, we can use our y equation, and we find that the velocity is 20 meters per second as the cannonball hits the ground.